production of sound. For sound to be produced, okay, what was the condition? Somebody else?
Vibration.
Okay, that's good. For sound to be produced, there must be vibration. So in short, all vibrating bodies produce sound. Can you give me some examples of vibrating bodies which produce sound? Okay, one. Yes, Rana. Vibrating bodies which produce sound. But all vibrating bodies of course produce sound. So examples of vibrations accompanied by sound production. Drum. What is that? What is it? Drum. Okay. Drum. When you hit the skin, it vibrates and then it produces sound. Another case? Yes? Pendulum. Does it produce? Does a pendulum produce sound? No, what a pendulum is. It is vibrating, but the sound it will be producing will be negligent. Yes? Tuning fork, when you hit it on the hard surface, the prongs start vibrating. And then sound is hard. We felt about that. Now, another case? Yes? Yes? Okay, the vocal cord of okay, then as I'm talking, there is vibration in the vocal cord where the tongue, the sound is being produced. Now, we have things like flute, whistle, we have guitar, the wire of a guitar when it is plugged, electric bell when the gong is vibrating, and hitting the gong will be set into vibration. So in short, vibrations produces sound. Now, sound of course is a form of energy. Sound is a form of energy. For example, if you flow air across the flute or the whistle, you are doing more on the air, and then they come in, they vibrate, and then sound is produced. Now, then the other factor there, the other consideration there was propagation of sound. Now, what is necessary for sound to move from one point to the other? Okay, Slanga. There must be a medium. So the medium must be there. Because that is where the molecules or the particles will have to vibrate. Sound, in other words, does not travel through vacuum. Now that can be proved using what we call the tail jar experiment, whereby the jar, we have an electric pen inside. Then when you pump out air, you will see that the hammer is vibrating, yet no sound is being heard when there is no air. But when you allow air to move into the pen jar, sound will be heard once more. That is a clear indication that sound requires a media for its propagation. Now then, we also talked about the nature of sound. A vibrating body. How does the vibrating body produce sound? And then how does that sound travels? We talk in the sense that a vibrating body creates a series of compressions and reactions as it is vibrating. And that will make the air particles to vibrate forward and backward in the direction of the propagation of sound. So in short, sound is a series of compressions and reactions. Now when those regions of compression and reaction reaches our ear, it makes what? The eardrum to also vibrate in the same manner, and then that vibration is transmitted to the brain and it is interpreted as sound. That is it. Now then, so sound is consists of series of compressions and reactions. Now then, we talked about determining the speed of sound by the pulse echo technique, whereby sound is produced, it reaches a barrier, it is reflected. So using the formula, that is speed is equal to distance over time. But there you have to realize that the distance will be twice because the sound moves, then it's reflected back. That is pulse echo technique. Now we need to calculate on that. And that one is normally tested. Now then lastly, factors affecting speed of sound in gases. The major factor there, which was depending everything, is density. It's density. So any factor which alters the density will automatically bring about a change in velocity. So in the gas. Now, so in short, any vibrating body produces